Let's see. So this is gonna be like a very short stream. I don't plan on doing this for a very long time. So, we're just gonna review algebra, okay? I feel like, I've definitely done a lot of, when it comes to problems and stuff, there's been a lot of, what is it called? There's been, I've done most of algebra, basically, is what I'm trying to say. So I feel like now, even though, yes, there are a few things that, we still need to look at, we can do a review of everything, So that's what this stream is going to be about. Now, I'm not going to do an entire review all in one stream. I might do it like a 2-part stream. So I'm not going to do everything, in this specific stream. But I will do as much as I can. Now, in college algebra, let me just emphasize, or make a list rather, of the things that we've gone over as far as college algebra goes. In algebra 1 and 2 as well, since algebra 1 and 2, they're basically what college algebra is. So let me just make a list. So we're gonna go ahead and do that. So number 1, so this is gonna be, I just want to start this by kind of, college algebra covered, topics covered, meaning topics that we've already covered. Okay. And I don't know if y'all can see the board. Let me just kind of, if I can, because I know that the camera is just not the best. So number 1, we've covered linear equations. That's the most basic type of algebra topic. Number 2, we've covered quadratics. So quadratic linear equations / functions, right? Number 2, we've covered quadratic functions. Number 3, we've covered, what else have we covered? Trying to see. We've covered quadratic functions, we've covered polynomial functions, right? Number 4, we've covered exponential / logarithmic functions, okay? Number 5, we've covered, I believe we did do square root functions, if I'm correct. I know I did it in a stream the other day, so I will say radical functions. Now, as far as graphing them, I don't think I've done that yet. So we're gonna do that, okay? Number 6, we've covered rational functions. Number 7, I'm trying to think. We've covered composition of functions, okay? Composition of functions is covered. And let's see. Number 8, we've covered rationalization, which is when we have something like that, you know, 1 over square root x. I don't know if y'all can see that, but it's like when we have something like 1 over square root x, and then we want to go ahead and rationalize, right? We've already covered that. At least I think we have. At any rate, you know, we've covered most of college algebra, really, enough for me to be able to help you guys, if you do take college algebra, to pass with a C at least, you know? I would love for people to tell me how much my videos have been helping people. But in this video, we're specifically gonna finally focus on, the final. And I know that, of course, I'm not a teacher. I'm in college, you know, so I'm not really I'm not saying that, you know, I know everything about how they do finals and how they do exams and all that stuff. I don't. But I know enough to know what kind of questions would be on an algebra final, because I've studied algebra so much that I know how it works. I know the topics, I know a lot of that stuff. So it's kind of, I mean, it's if you think about it, and one thing I didn't go over, which I will go over in this video, is the difference quotient, which obviously, that's very important when you get to, once you get into pre-calculus, you're gonna have to learn how to do that. Anyways, I'm gonna go ahead and just do some very random problems of like linear equations, quadratics, polynomials, rationals, radical functions, logarithmic functions, exponential functions, and like just all of that good stuff. So I don't have everything like written down as to like what am I gonna actually do and like what am I actually going to be looking at. I'm coming into this kind of blind, but I do know a lot of the topics, and I want to just, you know, hopefully this helps in some way for people who are in, you know, in school and they're trying to study for their algebra. But yeah. So let's get started. We're gonna do linear equations. Now remember that, and let me write that bigger. Slash functions too, because I kind of want to teach both things, you know. So remember that when we have a linear function, there is, of course, there's a line. So if we're gonna do this, we're gonna just go ahead and just try to draw a random line, right? Even though it's not gonna be perfect. Let this point be x1, y1. Let this point be x2, y2, right? Let this... Oh, and, well, that's okay. I mean, it's fine. It doesn't have to be on the axis, but, let me do that a little bit bigger because I feel like everything that I do on the on this board comes out so small. Right? We have something like this, okay? And we want to go ahead and this is, of course, this is going to be x1, comma y1. This point here is x2, y2. This part says rise, and this part is run, okay? Our slope m is defined as, so if we look at, I mean, I think my algebra professor from a long time ago taught me something very interesting. Well, basically, he taught me the way that we get point slope form, of course, but what I want to just kind of go over is like, you know, how to actually do, like what slope is. Slope is defined as y2 minus y1 over x2 minus x1. You may also have seen people, and let me kind of just zoom it in a little bit. Ugh. I really need to get a freaking I really need to get a better camera angle, or a better camera at least. This isn't the best. Anyways, this is what slope is. This is what we call slope. You may also have heard that slope is the change in y over the change in x, or delta y delta x, right? And so, let's see. So let's just kind of do a few problems, okay? We're gonna go ahead and just, you know, from like in general, like we're gonna say, okay, like what is, so if we have something like so determine the equation of the line that goes through 4, 2, and 6, -1. Just gonna say that. And I wish that, like I said, I wish I had a better camera angle, right? So we have 4, 2, and 6, -1. The way that we would figure out what is x1, y1, what is x2, y2, that's your first question. What is x1, y1, and x2, y2, right? That's your first question, is what are those what are those what are those points, right? If you look at, so one of the things that I always, you know, when you do these kind of problems, one of the things that I really recommend that you do is, you know, that you go ahead and kind of do a little sketch of, you know, how these look, right? If you know how to plot points, and let's just do a little review. If you don't know how to plot points, remember this is the positive x-axis, this is y, this is -x, -y. Remember, left is always negative, down is always negative, right is positive, and up is positive, okay? The x is the horizontal, it's like the horizon, okay? X-axis is horizon, horizontal, horizon. That's one thing that you really have to remember. So if we plot 4, 2, we do 1, 2, 3, 4, right? And we do 1, 2. Let me bring this a little bit closer so that y'all can see what I'm doing. And then we go ahead and say, okay, that's 4, 2, right? We can say, basically 4, 2 is like right here. And actually, I did it a little bit weird. Hold on, guys. Let me just redraw it. So again, this is 1, 2, 3, 4, 5, 6. This is -1, -2, -3, and -4. 1, 2, 3, 4. Okay. So, so the first point would be 4, 2, right? You would go ahead and do a little sketch. You would say this is 4, 2, right here. And then you have 6, -1. This is over here. You want to look from left to right. Always your points left to right. Okay? It always goes left to right. No matter what point it is, no matter if the line is decreasing, increasing, it doesn't matter. Always look from left to right. That will help you determine what is your x1, what is your y1, and what is your x2 and y2, right? Let me draw that a little bit better because it's kind of crappy. Hold on. So 4, 2, right? This is 4, 2, and 6, -1 is like right here, right? Okay. Now we're gonna draw the kind of like little line to represent that, or to say that those are that this is the line that we are looking at, right? And I know, this is a very terrible way of doing things. But this is, basically 4, 2, that's x1, y1. Okay? 6, -1 is x2, y2. x1 is lowest x value. x2 is highest x value. Okay? So the slope will be, so therefore, we can write the following. We can say, that the slope is y2 minus y1 over x2 minus x1. x1, y1 is 4, 2. x2, y2 is 6, -1, right? Okay. So, now our slope, we're going to go ahead and calculate the slope. The slope, if we let me just make some room. We're going to go ahead and do the slope now. We have m is equal to y2 minus y1, so we have -1 minus 2 over 6 minus 4. That'll be -3 over 2, right? So that's our slope. Slope is m equals -3 halves. Okay? Okay. I hope that's good. Ugh. Doesn't look as great. Hold on. Okay. So now we can now use one of the following equations. And of course, since this is not asking us to graph it, we can go ahead and do, we can just go ahead and do, you know, we can either do one of two things. So the first option is point slope form. Second option is slope intercept form, right? And if you want to use point slope form, you can do that. If I color code my points here, I'm gonna say that. So I'm gonna do a few things. X1, Y1, right? And then I just want to make sure that it looks good, because then, like, literally, and then X2, I'll do the red one. Y2, right? That's, so we have the following equation. Y minus Y1 and then equals, let me do M, I'll do it as green. M times the quantity times the quantity X minus X1, okay? Okay, so, okay, so now that we have this, we can go ahead and do, what is it called? We can go ahead and do, we can go ahead and fill it in. So, you know, basically x1, y1, that's this part over here. So it's 4, 2, right? We say y minus, and y1 is 2, right? So it's y minus 2 equals, and then our slope is right here. It's negative 3/2, right? Negative 3/2 times x minus, and then we have our x1, which is 2, or excuse me, it's 4. So it would be minus, where is my purple marker? Oh, it's right here. So it would be minus 4, right? And then you would go ahead and, you know, simplify that. And so then you would have, and I mean, in reality, if they just say equation, like determine the equation, and they don't give you a specific form, you can leave it like this, or you can simplify it. If they say slope-intercept form, you have to simplify it. If they say point-slope form, you can leave it like this. But for the sake of, you know, learning, we're going to just simplify this. So I'm going to take off the colors now because we finally have our equation. Y minus 2 equals negative 3/2 times x minus 4, okay? This is y minus 2 equals negative 3/2 x plus 12 over 2. This is y minus 2 equals negative 3/2 x plus 6. Then we go ahead and add 2 to both sides. We get y equals negative 3/2 x plus 8. And that is our answer. So that is, like, honestly, the most basic type of algebra problem that you're gonna have, like, in terms of, like, whenever they give you, like, oh, with a, like, determine the equation of the line, you know? Once they do, like, once they ask you, like, oh, determine the equation of the line where the slope, like, it's where, you know, that it's perpendicular or parallel to this stuff, then okay, that is a little more complicated. We're going to go over that next. So, let me zoom out again. Let me actually, hold on guys, give me a second. Okay. I'm gonna use this orange color. So, next, let's say we have a problem, and this time I'm not gonna use any colors, guys, so please pay very close attention. Whoever is watching this, pay very close attention, because, yeah, or if you do watch this later. So, we have, oh, this isn't the right one. Oops. Hold on, guys. Huh. Hold on. Interesting, okay. Okay. I don't know why I have two purple markers. One is lighter, one is a little bit different. Anyways, that's beside the point. Where did I put my eraser? Oh my goodness. There it is. Anyways, we're gonna do one that says find the equation of the line that goes through. I'm trying to think. I hope that's possible to do. I hope so. So it says find the equation of the line that goes through -1, 6 and is perpendicular to 2x plus 7y equals 9. Okay? So, I mean, obviously we can figure this out. So we can go ahead and what is it called? So we can go ahead and do this one. The first step that I'm gonna do is I'm gonna look at 2x, right? I'm gonna look at 2x, so (2x plus 7y equals 9). I'm gonna solve for y, right? I'm gonna say that this is minus 2x. Subtract 2x on both sides. 7y equals -2x plus 9. So then we're going to divide by 7 on both sides. We have y equals -2x plus 9 all over 7. You can also say y equals -2 sevenths x plus 9 sevenths, but they have the same denominator, so you can bring it together. It's okay. So, it's saying that it's perpendicular, right? Now, okay, in this case, yes, you want to go ahead and you want to go ahead and what is it called? In this case, you want to go ahead and like put it this way is what I'm trying to say. Oh, I'm sorry guys, it's like really late. So, okay. So, therefore, we have so this is our slope is -2/7, right? We want to find the slope of the line. And, you know, obviously in algebra they teach you parallel and perpendicular slopes, okay? So if, let's just kind of do a little squiggly line so that way so if we look at, you know, our slope is -2/7, right? If we have, so the theorem is if slope m equals a over b, then the perpendicular m, which is like, this is perpendicular, right? Is going to equal -b over a. So therefore, if we have m equals -2/7, then that means that the slope, the perpendicular slope, will be 7/2, okay? And that's the slope that we're looking for, because obviously, like, you know, we want to find the equation that's perpendicular, okay? That's our goal here. So basically, we know that we have -2/7 x plus 9/7, right? And we want to find the equation of the line that goes through -1/6. Now we already found our perpendicular slope, so therefore we can do the following, right? We can say y minus y1 equals m times x minus x1. Now, for this one, I'm going to say in slope intercept form. I don't know why. Intercept form, right? So, we're gonna say y. So basically, this is x1, y1, because it's the only point that we have, right? -1/6 is x1, y1, right? So we have y minus 6 equals, and then we already have our perpendicular slope over here. It's going to be 7/2 times x minus are, let me bring it a little bit closer so that y'all can see it. Seven halves times x minus our x1. Our x1 is right here. It's x equals -1. x1 is -1, okay? This is why I need to get another camera, because it doesn't show it as high of a resolution. If anybody knows, like, any good cameras, like I said earlier, if you know of any good cameras that I can get, or a good camera that I can get so that I can be recording better, please let me know. Anyways, our x1 is -1, so we're going to say minus -1, right? So it's going to be y minus 6 equals 7 halves times x plus 1. So then we have y minus 6 equals 7 halves x plus 7 halves. So then we add a 6 on both sides, right? So we already have, like, I'm just going to go ahead and erase this part, because we already have that part. That part's already done with. So then we have y minus 6 equals 7 halves x plus 7 halves, right? Oops. Y'all can't see that. Like I said, guys, if y'all know of any other cameras, please, 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 please let me know. So we add 6 on both sides, right? Okay. Now 7 halves plus 6, that's just 7 halves plus 12 over 2. So then y equals 7 halves x, and let me go ahead and do this so that y'all can see it way better. Hopefully that's a lot better. It's going to be 7 halves x plus 19 over 2. So then y equals 7x plus 19, and all over 2. Okay, that is going to be our final answer. Okay, now let's do because now that we've done systems of, or not systems of equations, now that we've done parallel and perpendicular slopes or whatever. Oh my goodness, this marker is just super stainy when it comes to cleaning the whiteboard. It's crazy. Anyways, or actually, yeah, we're gonna not systems of linear equations, excuse me. I don't know if I said that earlier. Anyways, we're gonna do linear equations next. So let's say I have something like okay, hold on. Where is my... Is this it? I think it is. Is it this one or is it another one? Hold on. Hold on, guys. Give me a second. Okay, it's this one. I don't know why. So let's do linear equations, right? We're gonna do... Oh, seriously? Two x plus 1 equals 5, okay? We're gonna subtract 1 on both sides, right? That's our first step. I don't know why this marker... Okay, subtract 1 on both sides. I know y'all can't see it because of the light. Oh my goodness. It's crazy. Let me just turn it off. I hope y'all can see better now. Oh my goodness. It's crazy. So, subtract 1 on both sides, right? And then you have 2x equals 4. Your number 2 is going to be divide both sides by 2. Get x equals 2. Okay? And that's your answer. It's pretty simple. Pretty simple. When it comes to... So if you have something like x plus 1 equals 9, same thing. You just do minus 1 on both sides. You do x equals 8. Simple. Very simple. I wish it could be like that for all of my math career, but it's not. So then they teach you distributive property. Distributive property says A times B plus C equals AB plus AC. Yeah, so That's the rule. A times B plus C equals AB plus BC. Or AB plus AC, excuse me. So if we have something like 2 times x minus 2, that's going to be 2 times x minus 2 times 2. That's just going to be 2x minus 4. Okay? That's distributive property. If I have... So I think... Oh my goodness, I forget all the time about associative and commutative property. And, sorry guys, hold on. So, that's the rule. So let's say we have something like, I don't know. Oh my goodness, this marker. I don't know why it's like that. Two times x minus 1 equals 4. Let's solve for x, right? So you just distribute your 2 in, right? You're gonna say 2x minus 2 equals 4, right? You add 2 to both sides. You have 2x equals 6. Divide by 2 on both sides. X equals 3, right? And that's how you do it. Now let's do a little bit of a harder one, okay? Let's say we have something like 2 times x plus 1 minus 3 equals 9. I know that probably it's not going to be a whole number as our answer, but that's okay, as long as we get the answer. We're going to distribute 2 times x plus 2 times 1 minus 3 equals 9. 2x plus 2 minus 3 equals 9, right? We're going to combine our like terms. 2x minus 1 equals 9. Add 1 to both sides. 2x equals 10. Divide by 2 on both sides. X equals 5. Okay. And I didn't even know it was going to be a whole number. Let's do a harder one now, okay? Let's do a little bit of a harder one. I'm only going like, I'm not doing a bunch of problems because, you know, I'm going a little tougher because, of course, like, you know, in algebra, as you go forward, it only gets a little harder because it's something that you've never learned before. And I don't want to do too much of one part. This is just a very quick review. It's not really like meant to be for like hours and hours and hours, especially because it's already very late. So let's see. 2 times x, or 2x plus 1 equals 3 times the quantity x minus 6 plus 9. We're going to leave the left side the same. We're going to distribute our 3x minus 3 times 6 plus 9, right? 2x plus 1 equals 3x minus 18 plus 9. 2x plus 1 equals 3x minus 9, right? And then subtract 2x on both sides, right? 1 equals x minus 9. Add 9 on both sides. 10 equals x, and you switch it around, x equals 10. Okay? It's not that hard, okay? Now, it's a little harder whenever they give you something, like whenever they give you distributive property on both sides, but it's not that bad, you know? Two times x plus 1 minus 9 equals 3 times x minus 5 plus 2, okay? We're gonna distribute our 2 in, right? Two x plus 2 minus 9 equals 3x minus 15 plus 2. This is 2x minus 7, right? Equals 3x minus 13, right? So then we have minus 2x on both sides, right? We get negative 7 equals x minus 13. Add 13 to both sides. And then we have 6 equals x. X equals 6. Okay. So now let's do systems of linear equations. So let me see, hold on. Give me a second, guys. I'm gonna look for some examples. So I'm looking for some examples. Hold on. And this is probably the last part that I'm going to go over for this stream, guys, only because, like I said, I'm not going to do everything, but I will do, like I said, I would, you know, there's only so much that I could do as, like, for tonight, is what I'm saying. Hold on. Let me 7x minus 12y equals negative 13, 5x plus 4y equals negative 19. So, we're going to solve by elimination. Okay. You can do by substitution, but that's just going to make it really messy. So, point is, like, to do by elimination, you just do, like, so basically whatever number you multiply, like if you're trying to cancel this one out, so let's say I do multiply by 5, and this one, like basically I do 7 and 5, right? 7, 14, 21, 28, 35, and then I say 5, 10, 15, 20, 25, 30, 35, right? So then, like, they both have a common factor of 35, right? Whatever you multiply this one by, you want to do the negative on the other one, okay? So this one, but you want to do, like, so basically 5 times 7 is 35, so to make it cancel, to make the 35 cancel, we want to say negative 7 times 5x, right? So then we have 35x minus, and we're going to distribute, right? 35x minus 16y equals negative 65, right? Then we have negative 35x minus 28y equals, and then 19 times 7, negative 19 times negative 7, that's like 133, right? So then we do negative 60 minus 28, that's negative 88y is equal to, and then we do 133 minus 25, or 65, excuse me. This one's interesting. I think there's going to be a fraction for this one. Let me make sure. Seven x minus 12y equals negative 13, and then 5x plus 4y equals negative 19. Right, that's what I thought. It is going to be a, that's strange. Hold on. 7x minus 12y equals negative 13, 5x plus 4y equals negative 19. Negative 35x minus 28y $63, right? And then I wonder what I did wrong. Did I do something wrong? Because it's 35x, right? 35x. I'm trying to see if maybe I did something wrong. I don't think I did. Negative 3.82. That's interesting. $133 minus 65 is 68. That's strange. I guess, I'm not sure why it's like that, actually. Because I'm sure I'm doing it right. I'm looking at Desmos here, and it's giving me something else for... It's giving me something totally different for... What is it called for, Oh, wait, oh, it's y. Okay, yes, I'm right. Oh my goodness. Sorry, guys. This is, okay, so y will equal negative 17 over 22. Now, if you plug that in to one of your, so basically you do 5x plus 4 times negative 17 over 22 equals, and this will be equal to, and let me move the camera so they all can see what I'm doing. Negative 19. And then 4 times 17 over 22. That's 34 over 11. So 5x minus 34 over 11 5x minus 34 over 11 equals negative 19. So if we move it up here, we can go ahead and do like multiply both sides by 11 to cancel out the fractions. So we have 55x minus 34 equals negative 19 times 11. So that would be 209, negative 209. We add 34 on both sides. Oh, oops, my bad. We're subtracting. So we are adding, but it's because it's negative, we're subtracting, okay? So we have 209 minus 34 equals 175. That's equal to 55x. So x equals 175 over 55, which if you simplify that, is 35. Or rather, it's negative, so it's negative 35 over 11. So that's how you do it. If I say like, and I know that I didn't do by substitution, I'm gonna do one more example and then that'll be it for this stream because I'm getting kind of tired. But and then tomorrow we can continue with systems of 3 because yeah, I mean it's it's a lot to cover. So we can say, so let me see, hold on. Oh gosh, hold on guys, give me a second. Okay, so this is going to be the last one that I'm doing for this stream, and then that'll be it because I'm kind of tired. So we're going to go ahead and solve for x, right? Right? On the second equation, we have x equals 2y plus 11. We're going to go ahead and plug that into there. Negative 7 times the quantity 2y plus 11 minus 2y equals negative 13, right? Negative 14y minus 77 minus 2y equals negative 13, right? Let me bring it a little bit closer so y'all can see it. Negative 16y minus 77 equals negative 13. So then add a 77 on both sides. Negative 16y equals 64, right? Divide by negative 16 on both sides. Y equals negative 4. And then x equals 2 times negative 4 plus 11, right? So then you have x equals negative 8 plus 11. So x equals 3. So your solution as an ordered pair is 3, negative 4. Okay. I know for the last one I didn't do an ordered pair, but yeah, that's how it would be. That's the real solution. Okay, guys. So I think that is enough for this stream. Whoever watched this entire stream, I thank you. I know that it was definitely something that, well, yeah, I don't usually do it this late, but, whoever, is watching, or whoever is still watching, I thank you. And, basically, well, yeah, I usually don't stream this late, honestly, and with, this is something that I do as my, kind of like my second job in a way, and other than college. So I really would appreciate it if any of you guys subscribed, because, well, yeah, I mean, as an individual, like right now I'm going through a lot. I recently lost my mom to cancer, so this is kind of something that distracts me from all of that, and just from everything that's been going on, like getting used to like the loss and everything and all of that stuff. This is something that I do just to kind of keep myself busy, and I really would appreciate it if, well, if whoever's watching, if y'all could subscribe, because that would really make my day, and it would make me feel like, basically like people are, what is it called? Benefiting from my content. So again, guys, I really want to thank you for keeping up with me if you did. Tomorrow, I think, if I do have time, I will stream again. So with that being said, guys, thank you so much for watching, and I will see you guys in the next